Earlier in the year, we learned this thing called transformations, which means you can take some function, in this case y equals x squared, the quadratic function, and you can subtract 4, which would translate it down 4 units. So your new graph would look like this. Or, much less intuitive, if you put the plus or minus with the x instead of outside the influence of the x, now it's going to move it left and right, and against your intuition, a plus 5 attached to the x will move this 5 units to the left, and so your new function would be over here. And we also learned that if you just put a negative out in front of your original function, and now you have a negative, what you would do is reflect it about the x-axis, or in other words, you would flip it. So my original function got flipped because of the negative. That's all review. Here's the good news. We're now going to take the same idea and apply it to exponential functions, which we've been working with lately. So it's not really new because it's the same concepts you did before. What I would suggest when you do this is, in a case like this where I have to move it upward 4 units, take a very obvious point like the x-intercept the y-intercept in this case, and just move that up 4 units. This intercept, when I first plotted my regular original parent graph, was 0, 1. If I move it up 4 units, the new y-intercept will be up there at 0, 5. I did have an asymptote here. That's going to go up 4 units. So 1, 2, 3, 4. Now my asymptote is right here, and my new graph looks like that. Basically, I take 2 obvious things and move them up 4, take the asymptote, move it up 4, and then recreate my graph. In the second example, now we have something attached to the x, so remember that's less intuitive. This will move things left and right, and it goes against your intuition. If it's an x minus 2, we're actually going to move it to the right 2 units. So in a case like this original parent function, I would now take that intercept, and it was at 0, 1. Now I would move it here, which is 2, 1. When I move the asymptote left and right, it still stays as this dotted line. So my new graph would look like that. Basically, if I moved it right 2 units, I can take that intercept and just move it to the right 2 units. If I put a negative out in front of the parent graph, so it's negative 2x, that's going to flip my function. So my original function looked like this. This is going to cause it to reflect about the x-axis. So it now looks like this. And my intercept, which it used to be at 0, 1, is now at 0, negative 1. And my asymptote doesn't flip because it was actually on the axis. Now we can do the same thing with just regular old function symbolism, which makes a lot of students say, ooh, I don't like that, but it's no big deal. So you take the e to the x, in this case the parent graph, and this says lower it by 2. So I would just notice my asymptote goes down 2 units. My intercept goes down 2 units. It used to be at 0, 4. Now it's at 0, 2. And you can just draw your graph from there. And what you have is your original function lowered by 2 units. This minus 3 has taken my parent graph e to the x and moved it 3 units to the right. And so my intercept of 0, 4 gets moved to the right 3 units. We're now at 3, 4. The asymptote, when it gets moved to the right, it doesn't change its elevation, so it stays like that. And now I can just recreate my graph. And the final thing to think about is, could you look at a new graph, compare it to a parent graph, and write the equation of that? So take a moment to pause the video and compare these two and see if you can write a new equation for this one. Hopefully you pause this to check yourself, because it's going to be easy to agree with me, but you would do the real learning if you did it on your own. Here was my original intercept, 0, 4, and it looks like this went down 3 and left 2. So I can even write that to myself. The down 3 is going to subtract 3. The left 2 is going to be influenced inside the x parentheses, opposite of what I think. So my new graph, I'll call this n of x, is my e to the x moved to the left by 2 units and down 3. So my old graph, left 2, down 3. And that is the new equation.